and just move on to the flow, which is some subset of some topics. So side in the previous system layer explanation mentioned Themis scheduler, which is a greedy-based load balancing scheduler of chunks. I'm gonna show how to use it. And also, for example, I will run congestion-aware network backend and see how it differs from the pure analytical backend. So Themis is a greedy-based scheduler to maximize greedy-based intra and interdimensional scheduling chunks smartly to maximize the network bandwidth utilization for multidimensional topologies. And more details are in our ISCA paper last year, so you can just refer to it. So the objective is here. The objective here is to make a 3D switch with 512 MPUs and run a 1 GB collective with and without Themis and see how the bandwidth utilization changes. So this is the 3D switch network info file. Simple. We just specify as 3D switch with 512 MPUs. And here I just set the link bandwidth of each switch to be 50 gigabytes per second. So the total bandwidth per each MPU is 150 gigabytes per second. And for baseline system info file, this is what's specified. The intra-dimension scheduling is just first in, first out, and interdimension scheduling is baseline, as the name suggests. But to enable Themis, we can create another system info file which uses smallest chunk first for the intra-dimension scheduling and Themis scheduler for the interdimension scheduling. Again, this can be found, the details can be found in the paper, this paper. So with the updated system info file, we can run this 1 GB overages on the 3D switch and see how the bandwidth utilization differs. So I will go on to exercise 3 and run exercise 3-1. So it runs ASTRA-sim twice with and without Themis scheduler. So here's the result, and I'll just copy and paste this CSV into my slides. So yeah, this is the reported result. So the base took about 35,000 microseconds to run 1 GB collective, but on the same topology with Themis, it only took about 13,600 microseconds. So ideally, we are sending out about 2044, and the bandwidth per each GPU and is 150 gigabytes per second. So ideally, with 100% bandwidth utilization, the collective time should be about 13,300. But the baseline took about 35,000, meaning the bandwidth utilization was only about 38%. But the Themis scheduler was able to drive this bandwidth utilization and achieved about 97.6% bandwidth utilization on the very same topology and the very same 1 GB collective. And this is the final exercise of run unaware and see where other backends than analytical can help. So we will make a 1D 64 MPU switch and run on a gigabyte overages, but using direct overages algorithm. This will create huge network congestion on the switch link, so the analytical won't report true correct numbers. So I question backend build script, so I can just go outside the folder and build congestion. And this will build the same ASTRA-sim frontend, but with the congestion aware analytical backend. And other backends like S3 and Garnet can be compiled in the similar way, and the description is in the GitHub repo. So I compiled the congestion backend. And this is the target metric system we want to simulate. We want the switch with 64 MPUs whose bandwidth is 50 gigabytes per second. And this is the corresponding network input file for congestion backend, which become much simpler. So this is switch topology with 64 MPUs with the same 50 gigabytes per second bandwidth. And we want to run direct or reduce algorithm. So this is the system input file. And with that, I will run the final demo. So the exercise 3 and run exercise 2. And this runs the same collective on the analytical backend, on the congestion aware backend. And this is the result. So here, because the analytical doesn't consider the congestion at all, the total time reported is really small, which is misleading. The congestion aware backend was able to model this congestion happening and reporting more accurate results. So as the demand for which network behavior one should simulate changes, one can just implement the network API that we explained before and use their own network backend as desired. So with that, I will finish my